Hello again. Calculus 2, I'm in 9.7. I wanted to tell you about these Taylor and Maclaurin polynomials. So this is this big crazy formula for the nth degree Taylor polynomial. You can make a polynomial centered at C that matches any function, that approximates any function. So notice I got some function, could be anything. It's approximated by this nth degree polynomial. And then here's what you do. F of C plus f prime of C over 1 factorial times x minus c to the first plus f double prime of C over 2 factorial x minus c squared. Maybe you know the next one. F triple prime of C divided by 3 factorial times x minus c to the third, and so on. All the way to an nth degree. That's an nth derivative, in parentheses, that n is in parentheses. That's an nth derivative of f, evaluated at c, over n factorial x minus c to the nth. So what you need to build this polynomial for some function is you need a bunch of derivatives, and you need them evaluated at c. You need the function evaluated at c, and then you need a bunch of derivatives evaluated at c. They become the coefficients. Now, they're not just the coefficients. They got this factorial here also involved, but they're part of the coefficient in front of the x term that is cubed or squared or whatever. So when c is 0, it makes it a lot nicer, and it's just a special name for, it's called a Maclaurin. It's just a Taylor polynomial centered at 0 as a special name. It's a Maclaurin polynomial. There's probably some interesting history there, but anyway, so it's the same formula, except c is 0, so I'm plugging in a 0 into the function. F prime of 0 over 1 factorial. Notice what happens when you have x minus 0. You don't have that quantity centered at c. You have x squared, x cubed. It's centered at 0. So let's try an example. Let's do this. So I give you a function. I'm going to build a polynomial and approximate it. I chose n to be 3 to keep it a little short. So that's a third degree polynomial, and I do want it centered at 0. So here we go. What do we need? We need the function evaluated at 0, and I need 3 derivatives. So let's go ahead and get the derivatives. F prime of x is the derivative. Derivative of sine, cosine, chain rule spits out a 2. You know that, I guess. F double prime is the derivative of cosine, negative sine. Chain rule spits out negative 4 sine of 2x. One more derivative. The third derivative is derivative of sine is cosine. It's negative 8, I guess. Negative 8 cosine of 2x. So I just need a bunch of derivatives. I need to evaluate them all at the center point C, which in this case is a 0. So I need f of 0. So you know, here I am. F of 0 means plug a 0 in here. You know the sign of 0 is 0. That's going to be this first term. It's going to be a 0 in this case. F prime of 0. I'm just plugging a 0 in. I could just write the number here. That's a 1. The cosine of 0 is times 2. That's a 2. The sine of 0 is 0. So f double prime of 0 is a 0. And f triple prime of 0 is cosine of 0 is a 1 times 8. That's negative 8. F triple prime of 0 is a negative 8. Those are part of my coefficients. Let's build this polynomial. Here it is. It starts with this term, 0. It's going to be a third degree polynomial. It starts with that term, 0. I know it's a little stupid. And then it's got f prime of 0, which is 2, over 1 factorial, which is 1, times x to the first. Awesome. And then it needs f double prime of 0, which is 0, over blah, 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 but that's just 0. And then I need f triple prime of 0. What's that? Negative 8. Negative 8 over 3 factorial, which is 3 times 2 times 1, which is 6, x cubed. So I'm finished. It's a short little polynomial. Here it is. I like it to be cleaned up. If you're working on these for me, I like them cleaned up. I like them exact. I don't want rounded off decimals. So I like these exact fractions. And that's the polynomial. We built a third-degree polynomial that matches this sine function. What you need to do is pick up a graphing calculator, graph the original function, graph this, and you'll see a picture. Let me see if I can, I'll just kind of, it's a sine graph. It's got an amplitude of 1 here. It's got a period of pi, but anyway, it's just a sine graph. So there it is. I'll just label this pi. It does have a period of pi. And then this. Oh boy, I should have, but I know what it's going to do. It's a cubic function. It's going to come down. This one's going to come down this way. I wonder how close it gets. I don't know. It's only cubic. We should have done a 4th, 5th, 7th. We should have done a 19th degree. Anyway, it comes down, it hugs the function for a while, and then leaves. And I'm not sure if I've got that approximately right. Maybe it hugs it a little longer, but it's centered at 0. This polynomial matches this function, and that's just a rough sketch. You should check out a good sketch. A lot of good homework in 9-7, building polynomials. It's easy to do with these formulas. You need a bunch of derivatives, evaluate it at C, and then you build the polynomial. Please simplify it and take a look at a graph. Thank you.